Hello everyone, this is Math 2, Lesson 921, excuse me. So we're going to be discussing how to solve quadratic inequalities today. So we're going to take what we know about quadratic equations and try to apply it to inequalities. And so it's a little tricky and it's not quite as straightforward as just basic inequalities, but the ideas that we have from all of our knowledge we're going to pull together. So we're going to start with an application because it helps us make more sense of our answers if we start with an application. So let's see what we can do. So during a field trip to the Minor 49er amusement park, Alfredo notices that a portion of the Gold Digger's Gulch roller coaster is shaped like a parabola. Near the base of the parabola, the track goes underground into a tunnel. A car on the track speeds towards the tunnel from 300 feet above the ground and then reemerges above the ground 100 feet to the right horizontally. Write an equation for the path of the car on the track. Let x equal the horizontal distance from the start, and let y equal the height of the car in relationship to the ground. State an appropriate domain for the situation. So it's important to kind of keep in mind that we aren't going to ride the roller coaster for the rest of our lives. That having x go on forever doesn't make sense. Having x be negative doesn't make sense. So there's things we have to kind of consider. So as we do this, we're going to get this out of the way so we can get more writing. And the first thing I'm going to do is kind of place my axes in my picture. So I'm going to place my y-axis vertically, and then I'm going to let the ground be the x-axis. And so what's the y-intercept? Actually, let's start higher. So the y-intercept. So the y-intercept is the point where we start where he notices where the parabola starts. 300 feet above the ground. So my y-intercept is 0, 300. What are my x-intercepts? So the x-intercepts are where it goes into the ground and when it comes back out of the ground, this roller coaster. Where are those points? So this, you can't actually tell from here, but this 50 right there represents our first intercept. Our first intercept is 50, 0. Can you find the other x-intercept? Yep, the other x-intercept is 150, 0. Because it came back out of the ground 100 feet later. Okay, so now that we know our two x-intercepts, write an equation for the path of the car on the track. So now we're going to use these to write the equation. So we have several different ways to write equations that we've learned in the past. I'm going to go ahead and kind of list them over here. We've got y equals ax squared plus bx plus c. That's standard form, where c is the y-intercept. We have y equals a parentheses x minus h squared plus k. That's where h and k are the vertex. And then we have y equals a parentheses x minus r1 and x minus r2, where r1 and 2 are the two x-intercepts. So since I don't know the vertex and I know the y-intercept, but I don't know anything else, I'm going to actually use this r1 and r2 because I do know the x-intercepts. So I'm going to go ahead and use that equation. And so I'm going to start with y equals a parentheses x minus r1. So what we do is we know this is x equals 50 and we unsolve it. So x minus 50 must equal 0 if I subtract 50 from both sides. So x minus 50 goes here, and the other one is, so x equals 150, so the other one is x minus 150. So we're almost done. We just need to figure out what a is. And so we're going to use our y-intercept to help us figure out a. So there's our y-intercept up here. And that's going to help us figure out a. So we're going to plug in 0 for x. And out will come the y-intercept value of 300 when we plug in 0. So we just follow this through a little bit. I'm going to use a different color. So we have 300 equals a times negative 50 times negative 150. 50 times 150, two negatives make a positive. It's 7,500. A equals 300. Let me just make sure that I got that math right. Yep, 7,500. Okay, so we're going to divide by A, divide by 7,000. So 300 divided by 7,500 equals A, which is 3 divided by 75. And so A is 1 over 25. So that's my A value. So I'm going to take my equation right here and my A value and put them together. And so my equation, which I will write at the top of the page because I'm out of room, y equals 1 over 25, parentheses, x minus 50, next parenthesis, x minus 150. Okay, so there's my equation. Now, what we want to do is just double check that this makes sense on decimal. So I'm going to go ahead and head over there. I've already drawn it. And so here it is, 1 over 25. And we can kind of see starting at 300, going into the ground at 150, hanging out underground, coming back at 150, and going back up. Now, where is our reasonable domain? So keep in mind that if I take this graph and I mean, it goes forever because that's what it does, but it's not reasonable to be on the graph state till x is 500 because look how high up I'd be. I'm way above 2,000. I'm not going to be 2,000 feet above the ground in a roller coaster. That doesn't make sense. So it's important that we kind of consider what we're dealing with here and what makes sense and what doesn't and how to kind of deal through those things. So getting back to our equation, where's our domain? So it said to state an appropriate domain, and I would say that our domain, I would say that x has to be bigger than 0. Obviously, it can also equal 0. When it does, we get our y-intercept of 300. And then eventually I'm going to be off the parabola portion of the ride. So based on this picture, it looks like it gets back up to as high as it was, which happens around 200. So I'm going to say that x is between 200 and 0. So that's my domain. That's what I'm going to say. Because how do I get 250? 150, another 50 probably to get back up where it was. And so that's where I'm going to use it. So there you go. Let's move on. So we're going to continue with this. When is the roller coaster below the ground? So it's below the ground when I hit the ground. So I honestly think it says we want to know when it's negative. So we've got our equation, 1 over 25, x minus 50, and x minus 150. Right? And it needs to be below the ground. And since the ground is the x-axis, I'm going to say it has to be smaller than 0. Okay, so there's my equation. Now, let's talk about the solutions. When's it below the ground? It's below the ground between this point and that point, right? When it hits the ground here and goes below the ground at 50, and then it comes back up above the ground at 150. So it's between 50 and 150. So I know the answer is between 50 and 150. Oops, that's not what I meant. Okay. So how do I write that as a solution? So I'm just going to kind of draw it for a second. It's not at 50 or 150. It's not equal, but it's all of these numbers in between. So how do I write that as an inequality? And so it's 50 is less than x, which is less than 150. Okay. When is it above the ground? So it's above the ground when x is smaller than 50. Over, like in my picture, 50 over there, right? And when x is bigger than 150. Now, it can't be both at the same time, so we're going to use the word or here. But then we also have that the limits on our equation to consider. We're going to leave them out of this particular, that it can't be 0 or negative numbers, and that we're eventually going to get off, and we're going to be out of parabola portion around 200. So, but we'll leave it here. And so my equation would then be 125, parentheses x minus 50, close parentheses x minus 150 is greater than 0. And the answers are right there. Okay. So now, why do we start with an equation, with a story? We start with a story because the answers, having the two answers between, makes more sense than when we do the math. So we're going to jump in and do the math now. We remember a boundary point is where the boundaries are. We're going to find our boundaries by pretending it's an equation. So step 1 is pretend it's an equation. And step 2 is to actually clear all the annotations. So step 1 is to pretend it's an equation. So we've got this equation here. The inequality x squared plus 2x plus 1 is less than 4. We're going to pretend it's an equal sign. So step 1, pretend it's an equal sign. To solve it, it needs to equal 0, because that's the rule when we're solving. And I have x squared plus 2x minus 3 equals 0. This factors into x squared minus 3, negative 3, positive 2, 3 and negative 1, 3x, negative 1x. So that factors into x plus 3 and x minus 1 equals 0. And so x plus 3 equals 0 and x minus 1 equals 0. And so x equals negative 3 or positive 1. Place the boundary on the number line. I'm going to go ahead and put negative 3 right here. 2, 1, 0, 1. And 1 goes right there. How many regions did I just make? So I took my number line and I broke it into 3 spaces. The number's smaller than negative 3, the number's between negative 3 and 1, and the number's bigger than 1. And so we just need to figure out how we're going to test our regions. We have 3 regions. Number's smaller than negative 3, the number's between negative 3 and 1, and the number's bigger than 1. Those are our 3 regions. Okay, so I'm going to test each region. So that what I'm due to test, I'm going to pick a number in the region. So I'll pick x equals negative 5, x equals 0, and x equals 5. Those numbers are in each region. So I test by checking out in this equation. So we're going to go back to that original. I'm going to go ahead and start with 0. 0 squared plus 2 times 0 plus 1 is 1. Is 1 smaller than 4? Yes. So this region, it was true. Then I'm going to test 5. I'll have 5 squared plus 2 times 5, which is 10, plus 1 is smaller than 4. Let's get a rectangle over here. And so 25 plus 10 plus 1 is not smaller than 4. False. So this is false over here. Now let's test negative 5. Use a different color. Negative 5 squared plus 2 times negative 5 plus 1, which is 25, minus 10 plus 1, which is supposed to be smaller than 4, which is not smaller than 4, so this is also false. And so that's false over here. And so it's true in between, and my solution is here, which means this is the answer. So it's a little intense, but it's important that we understand that there's always going to be 3 regions. And the difference between solving inequalities in these is you can just kind of leave the inequality there and then remember to switch the sign when you have to. It doesn't work here. You have to test regions. There's really not another way. All right, I'm going to give you these to try. Go ahead and try A. Pause it, try A. Choose the answers from the list, what you think it is, and we'll be back in just a second. Okay, so I factored. I got x plus 4 and x minus 3, so my boundary points are -3, -4, and +3. I tested points, which I didn't write down. I did that mentally. I plugged in 0. I got 0 plus 0, minus 12, which is -12, is less than 0. That's true. So it's true here. Excuse me, I just wrote false. It was true here. I tested 9, and that was 81 plus 9 minus 12, which was clearly way bigger than 0. I tested -9, which was 81 minus 9 minus 12, still way bigger than 0, so it was false in both of these spaces, which left me with the numbers in between. Okay, so that's your clue. Go ahead and try B. On B, we're going to have to use the quadratic formula. Hello, pen. Okay, so go ahead and try that. Okay, so this one is tricky. We've got our quadratic formula, 10 plus minus, -10 plus minus square root 100 minus 56 over -4. I've changed all the signs. So I have 10 plus radical 44 over 4, 100 minus 56. I'm going to leave it there. Calculator told me this was 0.842 and that this was 4.148. So that means 0 is outside of the boundary and 5 is outside the boundary and say 3 is inside. So when I plug in 0, 0 is bigger than 7, which is not true, so 0 is false. When I plug in 5, I get -50 minus -50 plus 50, which is 0. 0 is not bigger than 7, so the outside didn't work. I check 3. I get -18 plus 30, which is bigger than 7. So it's the numbers in between, and so that's what that is the numbers in between. And that's it. On this last one with the absolute value is much easier. Just remember, when we're doing absolute value, we're dealing with x, the absolute value is either 7, the stuff inside is either 7, or the stuff inside was -7. So those are our boundary points. So our boundary points are 9 and -5. And see if you can figure out where the solutions are. So I put that, pick your solutions from the list. Good luck. So if I put a number in between like 0, it's not true, so it's the numbers outside. So I just kept writing. I thought I had paused, but sorry about that. So I mentally tested without saying anything because I thought it was paused 0. Plugged in 0, I get 2 is bigger than 7, which is not true. So 0, which is in between these, was not true. So in between is wrong. I tested 10, which is bigger than 9. So 10 minus 2 is 8. 8, the absolute value of 8 is bigger than 7. I tested a number smaller than 5, like -10, which gave me -12. The absolute value of -12 is positive, and so it's 7. So it's the numbers on the outside. If I was going to draw it, I would have these boundaries, and I would have, so this would be -5, and this is 9. So that's what the drawing would look like. So there you go. Hope you enjoyed it. We'll see you guys soon.